Shall we start?
Yes.
Okay, today I am going to introduce a very important function. It's called exponential function. Okay, and this function is so important that you are going to encounter it almost everywhere. So I have brought few things so that you get an idea. Is it coming in the camera?
Yes.
Do you know what this thing is? This one.
Capacitor.
That's a capacitor. And what is this?
Inductor.
That's a piece of wire that I have coiled, okay? That is an inductor. This is of course a resistor and that's a diode. Don't worry about those. Oh, actually, now while I'm talking, I realize that even this guy. So, but not the resistor. So, we will see that when you put these things in circuits, the functions that describe their behavior, like how they are going to get charged in time, how the charge is building up in time, okay, or how currents are flowing in that circuit, all those are going to involve this special function that I am going to introduce today. And not just that, if you think of an object which is, let's say, a fossil which is dead for long, you want to know what its age is. Even there you will encounter this function. Okay? When you are studying about electromagnetic waves, there you encounter this function. So there are millions of places where this function you will encounter. So it's extremely useful that we learn about it. And once I have introduced this function, we will proceed with our development of differential calculus. Okay, so we have some motivation of studying this function. Now I am going to give you the definition of it, and it will not appear like something very obvious that this is a definition that we could come up with. But the reason that definition I am going to give is because when people study things, they see a certain object appearing over and over again, and it becomes useful to define that as a function. Okay, so I'm going to give you a definition. So I'll choose x as a variable. So the independent variable is x. Okay. So look at this. So I take 1. And add to it x and divide that x by, let's say, 2. Okay, I divide it by 2. Fine. And I take this same thing again. So 2 factors of it. Now that's something you can calculate. You can multiply these terms. Okay, so you can multiply these terms and it will be homework 1 times 1. So when you multiply these things, the way you should think is this, the way you should multiply is this. The highest degree, the term with the highest degree will be degree 2, and that you will get when you multiply this one with this one, degree 2 in x. Okay, so that will be a term proportional to x square. 1 degree lower will be degree 1. So that you can get in 2 ways. When you multiply x over 2 here with 1 or x over 2 here with 1. So that gives you term of degree 1. Degree 0 term you get only when you multiply this one with that one. Okay, so degree 0 term is 1 plus degree 1 term is something proportional to x that we can find. So 1 times x over 2 and 1 times x over 2. So x over 2 plus x over 2, that is x. I hope I am not making any.
It's correct.
It's correct. So that's 1 here plus a term proportional to x square, and that you get only when you multiply these two together, right? So there is only one way in which you produce that degree 2 term, which is x square over 4. Correct? Now let's take another one. 1 plus x over 3. And again I take x over 3, 1 plus x over 3 but this time I take 3 factors. Okay, and we can calculate this also. The lowest order, the degree 0 term, which is x to the 0 term, comes only when you multiply this one with that one with that one. Right? When you are expanding, the degree 0 term arises only when you multiply these 3. So that's one. Then degree 1 term can arise in 3 ways. Okay, so the degree 1 term is of course proportional to x. So how can you get that? When you take x over 3 from this one and multiply with that one and that one. See, when you are expanding, look at that term which you get when you multiply this with this and that. So that gives you x over 3. But then there are 3 ways of getting this. When you take x over 3 from here, 1 from there and 1 from there, that's one way. When you take x over 3 from here and choose 1 from there and 1 from there, that's another way. And when you take x over 3 from here and choose 1 from here and 1 from here. So there are total 3 ways, right? Choose either from here or from here or from here. So that's 3. So it's x over 3. And there are how many ways? 3 ways of producing it. Is it possible to change the slant thing to white? We can't.
Yes, it is.
Okay, we'll do it. Oh, you have to change that also, right? Okay, fine. Similarly, you can generate x square term, degree 2 term, which will be x square over 3 square. So that's this times this. That gives x square over 3 square. Okay, times 1. That's one way of generating it. Or you can take x over 3 from here, x over 3 from here, 1 from there. That's another way. Or x over 3 from here, x over 3 from here, 1 from there. How many ways? 3 ways. Okay, so this is 1 plus x square over 3. Okay, now you keep doing it like this. So next time when you take 1 over x over 4 into 1 over x over 4, what happened?
There's one more term, x cubed term.
Very good. And this number is, is that correct?
Yes, yes.
Correct, no? And let's say x cube over x over 3 whole cube. And that's only one way, right? When you take this, that's one. Thanks. That's the expansion. Now let's take 1 plus x over 4, 1 plus x over 4, 1 plus x over 4, 1 plus x over 4. So there are 4 such factors. So the number of factors I have is same as the number I divide x, the number with which I divide x. So if I am dividing by 4, I take 4 such factors. And I can again do the same thing. I can write its expansion. Now it turns out that in many applications, the following occurs very frequently. Now I am not going to show you in which cases it appears and how it appears, but I am giving you what appears, okay, what occurs so frequently, and we'll start from there. So what occurs so frequently is this. So you have 1 plus x over n, okay, so n is some integer, and of course, not of course, and it has n factors. So you have 1, 2 and so forth, n. So there are n products, okay. And what is the thing that we need to calculate most of the times is this object in the limit n going to infinity, where n is integer. Okay? So we positive integer. Okay? N going to infinity. If this is what appears frequently. And this thing is what is defined as a function called exponential of x. Okay, I'm being very careful in writing the notation. I'm not going to write it as e to the x. Okay, so if you already know this, that this can be written as this, at this stage there is nothing that tells you, at this stage there is nothing that tells you that you can write it this way, because say 2 cube has a meaning, it means 2 times 2 times 2, right? But you have no reason to believe that it is of this form, so I'm not going to write it unless I have shown you that I can. Okay, so even if you have seen this before, at this stage there is no reason that we can say we can write it that way. Okay, now when I write this, it's not clear whether this thing really exists, meaning, see here you have n going to infinity means what? You have infinite such factors. Okay, so 1 plus x over n, 1 plus x over n, 1 plus x over n, but n is, let's say, 1 billion. So you have billion such factors. So 1 plus x over billion and billion such factors. But not just billion, we want to take n to infinity. It might be that the right hand side, when you expand, all the terms 1 plus x over n plus whatever x square term with whatever quotient, they do not add up to any finite number. It might add up to give you infinity. Right? Is it fine? But turns out it is finite. So it makes sense to define this. Is this point clear? Now let's let's take this and proceed with this one. So let's see what I want to do next. I want to, so I'll write it in a more compact way. So it is, the definition is what? Exponential of x is equal to 1 plus x over n raised to the power n in the limit where n becomes infinite. Okay, n becomes finite. It's the same thing, right? There are n factors, so I can write it as power of n. So that's not any different. Okay. So let's calculate this. I want to put this in a special form, in a form which is, so let's take our function 1 plus x over n, 1 plus x over n, 1 plus x over n, and this is n times. Is this exponential function? No, because n is finite here. It's not exponential function. Okay. Now I take this and expand. The degree 0 term will be 1. Good. Because it occurs only when you multiply this with this with this with this. All the ones are multiplied. Degree 1 term. Degree 1 term is proportional to x. What's the coefficient? So you have x over n from here. X over n from here multiplied with 1. That is what gives you x over n. In how many ways that can appear? N ways. So there are n ways of choosing that factor. Okay? Either from here, from there. So there are total of n factors. And you can choose out of those n, from those n, one of it. Okay, you can have a look here. Total n items. I am choosing 1. Right? I choose 1. How many ways I can choose? I can choose this in n choose 1 ways. Okay? Which you in this case know it is same as n. So n choose 1 is n. Okay? Plus, now I want degree 2 term. Degree 2 term is x over n whole square If it is fast, let me know. Okay. X over n whole square, right? So we are looking at the term x over n whole square. In what way it can be generated? It can be generated if I take this and that, multiply together, and take one from everyone else, right? Or take this and that and take one from everyone else. In how many ways? That there are total n things and you are choosing 2 of them. So n choose 2. Okay, that's just a name I'm giving. By the way, those of you who have studied probability or combinatorics, they will know this. Okay, permutations and combination. But even if you do not know, that's fine. I mean, all I'm saying is choose 2 out of these n, and you can calculate how much it is. You have already done for when the n I had taken to be 2 and 3. In those cases, you did. Plus n. Now the pattern is clear. It should be what? N choose 3. Okay. Then we proceed like this, and then we come to the final degree n term, x over x power n. No, let's not write 1. That is correct. That is 1. But you have n choose n. N choose n. Okay. In how many ways you can choose n items of n items? There is only one way. So that's why n choose n is 1. Okay. So I'll give you the result, which I believe you know, and if you don't, do not worry. I'm just telling you what it is. So if you have n choose r, then this is n factorial. Is it in the camera or am I obstructing it?
No, it's the other light.
Okay, it's not in the right place, huh?
Yes.
Little left.
So shall I write here? Okay, I'll write it. So n choose r. If you have n objects and you have to choose r out of them, then the number of ways in which you can do it is n factorial over r factorial n minus r factorial. Okay, let's check. First one is n choose 1. N factorial over 1 factorial over n minus 1 factorial. So n choose 1 is n factorial over r is 1 in this case. So that's 1 factorial, n minus 1 factorial. Correct? This is what n factorial can be written as. N factorial can be written as n times n minus 1 factorial. Is that okay? Is that okay? You understand this? Because this is n factorial is 1 into 2 into 3 into 4 into so on and so forth up to n minus 1 into n. So n minus 1 and the remaining factors that make n minus 1 factorial, and I have written here. So divided by n minus 1 factorial. Okay, because 1 factorial is 1. So these two cancel and this leaves behind n. Okay, and that's why you know this coefficient is n. So that becomes 1 plus x. Huh? Now tell me what is NC2. If you tell me NC2, I will just put it here. Find out what I should write here. What is NC2? N choose 2. Shall I take it? I can do this, right?
No.
First, the first one. Hand.
Okay. So like it. Huh. Horrible. Yeah, tell me, what is n choose 2? So n choose 2 n choose 2 Mila, did you find? What happened? नहीं आ रहा है.
NC2 is n into n minus 1 over 2.
So let me write down. N choose 2 is n factorial over r factorial. R is 2, so 2 factorial
n minus 2
n minus 2
factorial.
factorial.
So it will be equal to
My goodness, what is happening? So this is same as
n into n minus 1,
n into n minus 1
n minus 2 factorial.
into n minus 2 factorial. Is this clear? Okay. Over, ठीक है, 2 factorial n minus 2 factorial. So n minus 2 factorial cancels and you are left with n into n minus 1 over 2 factorial. Is that fine?
Yes.
Very good, that is nice. Plus 1 over 2 factorial n into n minus 1, okay, times x over n whole square. So I will write it as x over n whole square because that is what it is. Good. Next one. एक और करते हैं and then we will proceed. I hope it's not difficult. Good. So let's have one more. Okay, tell me the answer. What is NC3? So that will be n into n minus 1 into n minus 2 into n minus 3 factorial
Over 6.
over, then you have 3 factorial coming from r factorial. R is 3, so 3 factorial n minus 3 factorial, and that n minus 3 factorial cancels here, and then you have 1 over 3 factorial times n into n minus 1 into n minus 2. Correct? Agreed? So this term is 1 over 3 factorial n into n minus 1 into n minus 2 x over n cube dot 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 plus,
N factorial.
let me write a term in between which is NCR, right? The rth term, the term which will have x over n to the r, some r, whatever r is. You are fine with r? So it will be what? N factorial, because it will have NCR. NCR will be r factorial over n minus r factorial. Agreed? Times, I will, okay, fine. Times, अरे भाई, or r, correct?
X over n.
3, 3, 2, 2, r, r.
X over n.
Yeah, thanks. Plus up to that term, right? NCN. So I will just leave it as n factorial over, again n factorial, and minus n factorial is 0 factorial x over n power n. Okay? Is that fine? So I have written for an expression. This is not the expression for exponential. Exponential has an infinity. Okay? This is an expression of 1 over x over n, the entire thing raised to the n. That's what I have written down. Okay? Now here comes the nice part. don't move it. Now let's rearrange things a little bit. Just a second. Okay. So this is 1, this is x, plus this is 1 over 2 factorial. Okay, look here. This is n square in the denominator. Here. Just pay attention. Write it later. And n square in the denominator. You have 2 factors here. I will divide each factor by n. So that way I take care of n square. So n square I divide here. 1 n I put below this, 1 n I put below this. So it becomes n over n, which is 1, okay, n over n times, when I divide n minus 1 by the remaining factor of n, it is 1 minus agreed? Is that fine? So I will remove n by n, that is 1, so n over n is 1, I will just write 1, okay? So I will just rewrite it. So this is 1 over n factorial, 1 over 2 factorial, 1, so that one I am not writing, this becomes 1 minus 1 over n x square. Agreed? Agreed. Plus, इधर देखो. Let's look at this one. 3 factors of n in the denominator. 1 factor of n I will cancel against this n, so that gives 1. Now I have 2 factors of n left. One I will put here, one I will put below this. So when I put below this in the denominator and divide, it becomes 1 minus 1 over n. That one becomes 1 minus 2 over n. Agreed? Okay, so you have 1 over 3 factorial here. That n cancels with one of the n's, that gives 1. The remaining two give you 1 minus 1 over n, 1 minus 2 over n x cube. Is that fine?
Yes.
Okay, let's come to this term now. Oh, it might be, light might be disturbing this, is it?
A little.
A little?
You just pull the board a little down. Yeah,
Okay.
that's-
So, is that fine?
Yes.
I can, that you all have seen already, so right, I can just move it away.
Yeah.
Now that looks cool. Is it cool? Okay, fine. ठीक है, साफ लग रहा है. So let's take now this term. So we do the same thing. You have r factors of n. ये क्या हुआ?
You have not.
I have not cancelled things, right? I have not cancelled things, but you can already see what will happen. We can cancel actually. We can. So let's do that. Let me do this part. So n factorial over r factorial n minus r factorial. This is same as n into n minus 1 into n minus 2. Okay, I should take more space. Let's do it here. I will plug it here next. So you have n factorial over r factorial n minus r factorial. So this I can write as n into n minus 1 into n minus 2 n minus r plus 1 n minus r. Agreed? Is that correct? No, that is not correct. 1, 2, 3, I have to reach up to r, so it should be r minus 1, not r plus 1. I'm increasing, right? 1, 2, 3, 4, up to, let's say, r is 5. So the previous one should be 4, 1 less than 4, or 1 less than 5. So this should be r minus 1. N minus r minus 1. Agreed? R minus 1, n minus r factorial. That's n minus r factorial. These are the remaining ones which make n factorial divided by r factorial n minus r factorial. Is it fine? Cover. So we cancel this. And you have now r factorial here. Correct, that's r factorial here. So now I'll take this result, plug it in here. So this is the first term only, right? This result is only this part. So when I plug it in here,
N factorial has nothing to do with R, right?
no. That's correct.
Then why is R coming in the expression of N factorial in the numerator?
Here? No, it's not. I'm making it that way. See, I'm arranging it that way. So you have 3 factorial, let's say. 3 factorial divided by 2 factorial. Let's say I have to simplify this. I want to write it as 3 into 2 into 1. That's 3 factorial. All I'm doing is I'm taking this one and writing as a factorial.
Oh, okay.
Right? So I write it as 3 times 2 factorial. That's 2 factorial. So that I can cancel the denominator. Is this fine? That's correct. It has nothing to do with r. Now look at this. Here, this will sit. But then I have n to the r in the denominator, which means this entire thing will get divided by n to the r. Right? So when I divide this entire thing by n to the r, this 1 over r factorial I'll keep. It has nothing to do with n, so that's there. Now the numerator is this, it gets divided by n power r. How many terms are there? How many factors are there? So 1, 2, up to r minus 1. So those are r minus 1 factors. But then the first one is n minus 0. So that's the first. So 1 factor from here and n minus r factors from here. Sorry, r minus 1 factors from here, which makes a total of r factors. So r factors here, and I am dividing by r factors of n. So I divide each of these by r, each of these by n. So n over n is 1, like in all previous cases. This divided by n will give you 1 minus 1 over n. This divided by n will give you 1 minus 2 over n. This divided by n will give you 1 minus r minus 1 over n. Okay? So you get 1 minus 1 over n, 1 minus 2 over n, 1 minus r minus 1 over n, and then, so everything is taken care of except for x to the r, right? Plus terms like this. Plus this is x over. Fine? Okay, good. Now we are almost there. So I'll erase this. Okay, we are here. Remember, n is still finite. Now this is 1 over x divided by n raised to the n. Let's take n to infinity, because that is what is exponential of x. Let's take n to infinity. If I take n to infinity, this is fine, 1 plus x. So take n to infinity. Okay. So limit 1 plus x over n raised to the n, which is this expression here on the top. In that one I should put n going to infinity. What happened? Why it's not writing here? It doesn't write here.
No, it happens sometimes.
Huh? Okay. Fine, it looks ugly, but it's okay. No, I don't like ugly things. ठीक है? अब तक ठीक है सब कुछ? अब इस एक्सप्रेशन में हमें n को इन्फिनिटी डालना है, करेक्ट? So I'll put n equal to infinity. That is what? In this entire, if I put n equal to infinity, first term nothing happens, it remains 1. Second term, it remains x. Oh, it's not working. Second term, third term, 1 over 2 factorial. You know how to use limits, right? What happens to this as n goes to infinity? It 1, because 1 over n becomes 0. 1 minus 0 is 1, so that's 1. What happens to this? Same 1, because 2 over n goes to 0. So 1 from here, 1 from here. So 1 into 1 is 1, x cube. So 1 over 2 factorial, x गलत हो गया.
नहीं, it's correct. X
नहीं
cube
है,
over 3
x square into one.
हाँ sorry ये वाला था. This is the one I am looking. So that is x square plus this one is 1 over 3 factorial x cube. So and so forth. And then of course you have all these other terms, right? It keeps going on. It never stops. So the pattern is always this. That's why I wrote raised to the power r, where r is arbitrary integer. So you, is that fine? This is
Yes.
this exponential of x, which is this object.
You can write the last one.
There is no last term.
No last term.
It's infinite series, right? N is infinity. I have taken the limit already. Taken the limit now. So there is no last term. This is infinite. Okay. So it keeps going on. That's why I am writing dot dot dot. Okay. So
Last term will be 0.
No,
Last term will be
there is no last.
नहीं. It will decrease.
It is no, not necessarily. I mean, yes, but from here I cannot say that is correct. Yes, but then I have to argue. See, the coefficients are always becoming smaller and smaller.
Yes.
If it was not,
If it is decreasing, then last term will be 0.
Yes.
Because it implied.
there is no last term. Infinity is not a particular term, right? It's not like infinity is that term. There is no such nothing like that. There is no last. But it is decreasing. That is important. But I will not go into that detail. It comes back. It is asking the same question, whether this sum of infinite things is finite or not. Whether this sum up to something, some finite number. And for that, it's important that these terms become smaller and smaller as you go to larger integer values. Right? So this is what is exponential of x, right? Because this is what we call exponential of x. So this is exponential of x. Again reminding you, I am not writing e to the x. Okay? That I have not justified that I can write it that way. Okay, up to fine here? Claim without proof. That the series gives a finite value. Gives a finite value for every finite x. Meaning if you choose some finite value of x, exponential of x will give you a finite value. Is that fine? Okay, good. So let's have some fun with this. Are you with me? Are you tired? No, of course you are not tired. I can see that you are not tired. Okay, so let's proceed. You can remember this expression?
Yes.
Hmm? You're very excited. Okay, so let's go to next page. So let's write down. So I have defined a function for you, which is this. And it's very useful to remember the original expression 1 over x over n, 1 plus x over n raised to the n, okay? The limit n going to infinity. Because when you are solving some problems, it is that form which will come. And then you say, oh, this is exponential function. And then everything else that I am going to tell, you can apply there. Okay, so always remember that. Or maybe I should do that. So what we have is, so summary so far, okay, I'll just summarize. Exponential of x is 1 plus x over n to the n, limit n going to infinity. And I have shown you just now that exponential of x has this expression. Is it fine? Okay, so let's ask let's find out the values of this function at some special points. Okay, so what is exponential of 0? What is exponential of 0? 1. 1 plus 0 plus 0 plus 0 is 1. Okay, let's look at exponential of 1. No, don't do that. No. What is exponential of 1? This is, I put x equal to 1. So it is 1 plus 1 plus 1 over 2 factorial, x square is 1, plus 1 over 3 factorial, x cube is 1 because x is 1, and so forth. Is that fine? But I told you, I made a claim without proof, that exponential of x, what happened? Too cold. That exponential of x gives you a finite number for every finite value of x. 1 is a finite value. So this thing, whatever this right hand side is a finite value. It's some number. Okay? We will give it a name. We will give it a name and we will call this entire sum to be E. Okay? That's E. That's the definition of this number. So what is E? What is the number? That number is this. It turns out this is not a rational number. It's a irrational number. It's a transcendental number. Okay? Now let's estimate the value of E. Roughly how much it is. And that's an important exercise. Is the question clear? Are you following? Are you with me? Okay? So I'm saying this number is E, but let's get an idea of how much it is. So take out your calculator and make sure you don't make any mistakes. Let's do it live. Okay? So estimating the numerical value of E okay. So E is equal to this. 1 plus 1 is 2, right? 1 over 2 factorial. 2 factorial is 2. So 1 over 2 is 0.5. So I'll write, let me write it this way. So 1 plus 1 is 2. I write 2 plus 0.50 plus. What is 1 over 3 factorial? 1 over 3 factorial is 1 over 6. How much is 1 over 6?
0.166.
0.166. Okay, let's take the next terms here. that is 1 over 2 factorial, right? Let's take 1 over 3 factorial. 1 over 3 factorial is 1 over 12. Sorry,
4 factorial.
4 factorial. 3 तो ले लिया आपने.
कहाँ ले लिया
No,
फिर?
1 over.
हाँ, sorry.
3 factorial
Just a
is
second.
1
The
over
arrow
6.
is, the arrow is wrong.
Arrow is wrong.
Mm.
This is this one.
This is 1 over 3.
This is this one. Yeah, 1 over 4 factorial.
1 over 24.
0.041.
4 factorial. Huh?
1 over 24.
So 4 factorial is,
1 over 24.
now how will this go? 4 into 3 into 2 into 1. 4 to 12, 12 to 24. So that's 24. So how much is 1 over 24?
0.041.
0.041. How much is 1 over 5 factorial?
0.008.
Okay? Maybe give me 1 over 6 factorial also. Give me 6 factorial also. 1 over 6 factorial.
0.001.
Are you sure?
Yes.
You divided by 6 factorial or you first took calculate? Huh.
1 divided by 6 factorial.
This one is
0.001.
3.
1388. A lot.
ठीक है. Okay, let's do one more thing. No, let's not do. Okay, fine. Let's stay with this. So I will give you, it will require some convincing, but you can roughly see. If I want a result accurate to the first decimal place, then you see here it's 0.5, then you add 1, 0.1, the next one,
0.
it gives you 0, but there is a 4, maybe others one can add up and give you something which changes that digit, but the other one is really 0, so and they are all going to be 0. So they are not going to add up much. Maybe the third one can add up eventually to give you something here. But we can almost see that this number will converge very fast. So it is 2.5. Can you add these up?
Yes, 2.716.
No, do one thing. Okay, that is fine.
716.
You have added them up?
Yes, added them.
Okay. So these last two digits we cannot be sure,
Close.
but this one is good. So because there are all other terms also, right?
2.71 is fine.
2.71 is fine. Okay.
Yes.
So you see, let's stick with this number 2.7. So it's approximately 2.7. So a little more than 2, a little less than 3. It is between 2 and 3. So this number E is between 2 and 3. Okay? Good. So I know some things about it, but that's very little. I am going to show you something very dramatic. Now it's dramatic. Okay? It's going to be dramatic. I can take some water. No? Tired? Okay, okay. Let's continue with the dramatic thing a little later. We can, we stop here. I'll show you some very nice properties of this function, and then that will explain why in the books people write e to the something. But I'm going to now make a case for that. Okay? Okay, see.